Okay, as you can see, in our chapter number 2, we are dealing with first order linear equation, and that we is solve the quasi-linear one. Again, first order non-linear. Okay. In chapter 3, we can go for second order non-linear case. Okay. So in this, we have seen Lagrangian method. Here we have seen Chapitz method. Till we are in here. Okay. So we will hopefully we can finish today. Okay, what about others? Okay, so here, since of the time being, I'm gonna give you some exercises for you to refer. Okay, it's not about everything I teach you. You have to learn something as well. So from your knowledge of ODE, okay, so please find out these topics. Okay, complete integral. So what is the meaning of complete integral and what is, and some exercises. Okay. Also, what is particular integral? Can abbreviate as PI. Okay. Similarly, singular solution or singular integral. So it's not like just to write the topic. You have to write down whatever you have found out. Okay. In the notes also, you put the heading and write down something, whatever you are finding in any way in the books, or and in any form you can find the answers. Okay, just everything are already taught you. Okay, only thing is you have to find the correct headings and all. Okay, so I don't have time to type and give you these things. Just you you try as exercise. I will check anyhow. And then what is the general solutions? These are find the definitions. Okay, definitions and the methods and all, and some examples. General solution or general integral. And then this one, compatible solution, system of solutions. Compatible system of first order. Okay, compatible system. So in this you can also learn what is non-compatible. Okay, and what is common solutions or no common solutions, or no solutions. So in these terms you can find out under the compatible system of first order. Okay, so these are your exercises. Okay, so yeah, so this is your exercises. You can find the definitions and some exercises. Okay, all right, now let's continue our after the Chapitz method. Okay, let's see some special cases. Special, this is a heading. Okay, special cases of non-linear PDE. So we're still in the first order, so no problem. Okay, let's see type 1, 2, 3 or case 1, 2. Okay, so special cases. Since special cases, I'm gonna take the case 1. Okay, or type 1, anything. Okay, Let's say my function in the form of f of p comma k is equal to 0. This is our case 1. Okay, this is the form of case 1. Okay, the function has only the terms of p and q. So you know what is p and q, isn't it? So it means f is, so you can choose f is independent of other variable like x, y, z. So commonly in these courses, we are taking x, y, z as well as p, q. Okay, so we don't need to think some extra variable. Just keep like this. Okay. So in this case one, we only have the function of p and q. We don't have any terms of x, y, z. Okay. So solution will be for this case in the form of z is equal to ax plus by is equal to c. Okay, where a, b, c are arbitrary constants. Okay, so if you find something this form, your answer should be in this form. Okay, so from this you can build up the thing. So here also we're gonna prove this one. Okay, so we can't tell this equation has this solution now. So let's prove this. Okay, using our Chapit's method. Okay. But in the solution, you don't need to use the Chapit's method. Just use the solution, this solution, this one. No need to prove, okay, in the solution process. But in here, for the education purposes, we are proving. So sometimes the question may come, prove this equation has this solution. Okay, so in that case, you have to know how to prove it, okay, using the Chapit's. Okay, so let me continue the proof. Okay, let's prove quickly. So we have only 40 minutes. So we have 4 cases, okay? So let's finish up today so it's easy for us. So fx will be 0 because it's not depend on x. Similarly, fy also 0, fz also 0, okay? But fp, yes, I have. So I'm gonna take this as fp, and fq, yes, I'm gonna take as fq as it is, okay? And in Chapit's, so Chapit's equation. So I'm not gonna write, okay, you just write the Chapit equation. I'm gonna substitute only, okay? So in this, you have to write the actual Chapit's equation, okay? dx over, what is our first one? fp, no? fp is equal to dy over fq, which is equal to dz. You can, I'm writing the simplification. You can write fully, okay? Plus q time, yeah, fq, no? Again, minus dp over 0, minus dq over 0. All these things I'm going to take as a k because everything are equal, no? So if it is same constant only, it will be equal, no? So that's in that case, like auxiliary equation, I'm taking as a k equal to k. I'm taking one k as a constant, okay? So let's solve first of all this one because this equation, first equation only depend on p comma q, no? So we only have that terms. So first of all, I'm going to take these two, okay? So if I take dp over 0 is equal to k, then my dp will be 0. Okay, so integrating, what you'll get? P is equal to some, let's say A. A is an arbitrary constant. So we are, you have to write the correctly, okay? The things, the steps very correctly. So, but what is the P actually? You already know this is the notation we use for what? Daba z over daba x. Isn't it? So this should be equal to A. So what is z now? So z is a function of x and y, we know. But yes, in terms of x, we have ax. But will you put b? So this one, okay, ax. So we have to put another constant, no? But actually, since the function is uh, a multiple variable, one x and y. So if you are taking with respect to x, okay, so this is like partial, you have to write here like this, partially, sorry, this one, no? So integrating. So this is integrating, you have z x comma y. So we have to know this z is a function of two variable. So here you have to take the other one as a function of y. It means this we don't know. Maybe some y. That's why we got a 0 here. Did you get that? Okay, I will explain again. Please write down these things. Okay, in here I'm just taking this and this. Okay, sorry. So next one only I'm gonna take these two. Okay. Okay. So what I mean is, so we know da bar z over da bar x is equal to a. Okay. For example, let's say my z is equal to, z is a function of x comma y now. So let's say x square plus y is 2y. Okay, plus 6 or something. Okay, so if you take da bar z over da bar x, okay, so I am gonna only take the z function, others are 0 now. So this will be 2x plus 0. Am I correct? But if they say from here to here, like a reverse action, okay, we don't know 0. It can be any constant or any function of y also now. Even though it's a function of y, if I take the partial derivative, I'll take 0. So it's better you to, when you are taking, if it is 2 variable or 3 variable, you have to write the other one. Okay, so this will be ax, other one as a function of y, maybe 2y plus 6, or sometime this may not come. In that case we can put as b. Okay, but we don't know, no, so we can't take always a constant. You have to take as a some function of y. Okay, yes. Then again, so this is one of the equation, let's say, but still we don't know a, no, a is whatever we took. Okay, a is fine. We have f of y, so we have to solve again. Okay, so that's what we are taking. Okay, again partially, continue this one, partially differentiate with respect to y. Again this one, partially differentiate equation 1 with respect to y. So what you'll get, this will be da bar z over da bar y, which is equal to, do you have y here? No, no. This will be, yes. So I'm going to take f dash of y, or da bar f or da bar y. I'm going to use this notation. Okay. Okay, let's keep this one. But by Chapit's equation, let's continue other one. Okay, dq over 0 is equal to k, isn't it? So this will be dq is equal to, again, 0. So if you integrate again, this what you'll get, q is equal to, let's say we have 0 only, no? This case, okay, we have only b. Okay, where b is an arbitrary constant. This I can take as 3. Okay, question number 3. So I'm not going to go other window. Please check this one. What is q now? Q will be da bar z over da bar y, no? Da bar z over da bar y, which is from the equation number 2, 3, we can say Q is equal to dabba z or dabba y, which is equal to f dash y. Similarly, which is also equal to b. Okay. Okay. So let's take this one as 4. Are you all with me? If you find anything harder or if you don't understand also, you can let me know. Okay. So if you are silent, it means I'm okay. Okay, let me continue. We're still not finished. Okay. All right. So from the equation number 4, we have what? F dash y is equal to b. So again, you integrate with respect to y. We are finding some relation with respect to y. So we'll get f dash of y with respect to integration differential equation. You cancel out. So the original equation will come. And this will be, give me a second. Okay, this will be integration, no? By. Again, we have taken x and y. So we don't have nothing. We are taking c. Okay. So this one you have to know function of y. Okay. If y means, sorry. Give me a second. Okay, this will be function of y. Okay. So where, if you are taking anything yourself, you have to tell what it is. Arbitrary constant. Okay. Okay. Now what is our z? Is that the equation number 1 or something? Okay. I don't know. Z is equal to, we have take ax plus fy, isn't it? So we have find the relation for fy. So that's what the happening. Okay. Then you can substitute ax again by plus c. So this is our solution. Okay. Hence proof. So what we have done is, first of all, this is our equation p comma q. Okay. This is only terms we have. So using the Chapitz, we have found dp over 0, dq over 0 is equal to k. Okay. So from P, we take A and then we take dabba z over dabba x. Okay. In terms of dabba z over dabba, if you're taking integration, you have to take ax plus you have to use one of the function of y. If you are taking integration with respect to x. Okay. Then we also have this one. Again, we find the q is 1. And q and fy are same. So we are equating. Then we arrive this one. So from this, we can conclude this equation has the solution of this one. Okay. So in the example, you don't need to, derive this much. If you find this case, you use this equation, find the answer. That's all. Okay. So let's do one example. So I need to finish these cases today. So make it faster. Okay. Possible. So for example, you can find some example as well. For understanding, I'm just doing this one. Okay. For example, if you have, let's say, f p comma q, so they won't give you in this way. They just give you f of q squared minus 3p squared, which is equal to 0. Okay. So you have to know, okay, this is under this case. Okay. So if it is in this case, you have to know these functions is independent of x, y, and z. Okay. Therefore, by case 1, we have z is equal to ax plus by c. The solution will be this one. Okay. So here you can see, yeah. So from the derivation, we have found p is equal to, use the Chapitz. Okay. Use the Chapitz, then you can find p is equal to a, any a. Okay. Again, q is equal to b. Okay. So you can see our from this one, you can find one relation of A and B. So if I take this one, equation 1, if you substitute these things in the equation number 1, you will have B squared minus 3A squared is equal to 0. No? From that, what is B? B will be, can take this side, so 3A squared, so square root, then square root of 3A, isn't it? So plus or minus. Okay. Therefore, just substitute. So this is our equation. So from equation number 2, the solution will be that is equal to A will be A as it is. Okay. A x plus for the B in terms of A. So I have square root of 3A y plus C. This is my final answer. So similarly, you can find some exercises here. If possible, I will find. But you better find yourself. Okay. Case number 1. So I'm going to go a little faster to, get the things finished, possibly. Okay. This is case number 1 and the solution. Similarly, let's go for case number 2. So you understand this, no? Just you have to use the Chapitz to, this one we already derived. A is equal to B is equal to B. Okay. Then you find from this given equation, you have to find a relation between these two, A and B. Okay. Then you can substitute. Okay. Where you have to tell A is an arbitrary constant. Okay. Where A is an arbitrary constant. A comma B. And then we also change into A. Okay. Okay, I will go for quickly these cases. Okay, so you can do as exercise. So case 2 will be, okay, today is a Friday, no? I have to finish quickly, so I'll give you quickly, okay? Let's say F is, so first case is F is independent of X, Y, X, Y and Z. But case number 2 is F is independent of X and Y only. Not on, it will be, Z will be there in the equation, okay? In that case, okay, the solution will be, solution is Z is equal to pi of X plus AY, okay? So the function will be like in this way, F of PQZ, PQZ is equal to 0, okay? So using the Chapitz, solve this one. This is a proof. Proof is yours exercise, okay? Like in like what I have done in the case 1, you just use the Chapitz to prove this one. So this you have to get this one, some function of X plus AY. Okay, this is your task. Similarly, case 3. So example, one of the write this example also. Q squared minus 2p squared, sorry, Z squared p squared 1 minus p squared is equal to 0. Okay. Sorry, Q is equal to, okay, not 0. Q squared is equal to Z squared p squared times 1 minus p squared. This is the example of this case 2. Okay. Okay, case 3, the function of x, y, as well as p and q. Okay, it will be in the form of x comma h comma x comma p minus g of x y comma q. Okay, this format. So the solution will be, okay, solution is that is equal to integration of pi of x dx plus integration of let's say chi of y qy dy. It's not pi x chi x, our earlier not 1, whatever your function of x, function of y. Okay, so this is the final solution. So you can prove this one also. using the chapits, or yeah, chapits. So use this one to chapits, and then you can derive. And case 4, okay, I will finish now. Wait. Case 4 is we called as a clear roots. Okay, clear. Give me a second. Spelling is CLARAUTS, clear roots form. Okay, so this is a form of, okay, give me a second. So this will be in the form of this one, that is equal to px plus qy plus g, any function of p comma q. Okay, this one. The solution will be that is equal to ax plus by plus g of a comma b. Okay, solutions. So that's all the cases. Okay, you can prove everything. Prove yourself and find some, if possible, I will find some exercises as a homework. Okay, so that's all about our chapter number 2. I will begin my chapter 3 in next class possibly. Okay, so I will finish here because of the Friday. Okay. Okay, thank you very much, everyone. Please take a screenshot if you need it, anything, and do the things. Okay, all the proofs and exercises, examples, and homework quizzes. Okay, and let's meet you in the next class.